Hi, good morning everyone. I just want to remind you that I have created a practice exam until Friday. And today we're going to solve our remaining question from 3.5. And if there is going to be some time left, we can start a little bit of this practice exam questions, okay? And there was only one graphing question left in 3.5. We're not going to start anything new today, so it's 3.5, the cutoff. We will first solve this question and then I can take any general questions if you may have about the exam, and then I will solve just questions as much as I can. Okay. We were about to graph a rational function. Let's first remember what a rational function was. It's basically a ratio, numerator denominator, but not every ratio counts. The top and bottom should be polynomials, such as this is not a rational function. Why? The denominator is a polynomial, but the top, this is power 1/2. It's not a polynomial. We do not consider this as a rational function. Although it's a ratio, we just call them quotients, not rational function. This is a rational function. And yesterday we learned about their asymptotes, or what happens when you get close to that excluded value in the domain. There are some bad numbers when you enter them to the function. Function behaves unexpectedly, like infinity or minus infinity. We call them vertical asymptotes. We found them. We also found horizontal asymptotes. Sometimes your function lean towards a horizontal line on the far ends only, not the middle side. It's called horizontal asymptote. We found them as well. Sometimes you may have a slant asymptote, so you need to go check as well, slant asymptote. We already knew odd even functions or symmetric functions with respect to y or origin. So we also reviewing this to make the graph of the function, and then we plot some sample values and sketch the function. Okay, so there is nothing new you need to know at this point. It's just review of past subject and pretty much everything we covered in this class so far, right? Okay, let's start with step 1. We are going to first determine the y-intercept. We have done this in the past. I did a little bit differently. I call it y-intercept. I immediately set something to 0. Set what to 0? X to 0. If this is y, you're always choosing the opposite variable and setting it to 0. In where? In g of x. So you're gonna plug it in g of x as 0, and compute this. By the way, g of 0 is now going to be called y. That's the y value. And y is -9 over -3. 3. You know what I like actually? When I get some information, I don't collect and compile all those, make a pile of all this information on the page. I immediately sketch it, put it into the graph so I don't lose them. So take a separate side and put whatever information you found here into the picture. 3 is found, which is the y-intercept. It's technically x-coordinate is 0. So 0, 3 found. I'm going to mark it. Okay. Next, step 1 over step 2. We are going to find out x-intercepts. And for this, we always setting the other variable, y, into 0. In other words, this guy is y. I'm going to set that into 0 and solve. Alright, how do I solve this thing? It's a fraction, set it into a number. Whenever you have a fraction, you definitely have a denominator. We can't solve something with a denominator unless you cancel that denominator. How do you cancel it? Multiply. We multiply both sides by x minus 3, left and right, both. However, there is something beautiful here. If one side of an equation is 0 and you multiply with anything you wish, it always turns to 0 again. In other words, if you have a fraction, set it into 0, all you need to do is wipe off the denominator. Denominator just disappears. Look, what's left is numerator. And we get x equal what here? When you bring 9 to the other side, x is 9. In other words, 9, 0 is the x-intercept. Alright, 9, 0. About here. Your curve should go visit these 2 points on y and x respectively. Any questions? Alright, let's do number 3. Identify any vertical asymptotes and graph them as dashed lines. Alright, take a look at your graph, your equation. Are there any bad values? You enter into x and this function becomes uncomputable, undefined. 3. First off, actually you need to factor top and bottom and reduce them, but there is no factoring involved here. X minus 9 and x minus 3 are irreducible, they are not factorable. So you just check out what makes the denominator 0. Simply you see it's 3. Or set x minus 3 into 0, x equal 3 is your vertical asymptote. Okay? And let's move this information to here. How? We need to make an electric fence so that your function cannot visit it. Where x equal 3. So at x equal 3 is probably somewhere here. Okay? Any questions? Let's name this thing. So can you imagine your graph going towards this, maybe up, maybe down? Okay, there is going to be something happening around this line. Number 4. Do you have a horizontal asymptote here? What was the horizontal asymptote test? I think it involves determining m and n. Or we first do n, right? What is n here? Do you need to remember that? What is n? N is the power of the top. M is the power of the bottom. There are 3 cases. If top is more than bottom, then we have nothing. If top is less than bottom, we have y equals 0. If top equal bottom, it's the ratio. Alright, which situation do you have here? What is n and m? Hmm? 1 and 1. So n equals m. So do we have a asymptote? Yes. How do I get them? We take the numbers in front of those biggest leading terms. We call them leading coefficients. 1 over 1, which is 1. So y equals 1 is the horizontal asymptote. What do I need to do? You're gonna make that line horizontal line now. Y equals 1 is somewhere here. Agree? Any questions? Simple enough, huh? Because our function is so simple. I'm glad they didn't give me anything with squares or stuff. Alright, number 4 is done. We're going for number 5 now. Now, you do have a horizontal asymptote. The question is, does my curve come and cross this horizontal asymptote, maybe in the middle somewhere? I know on the very far ends, it leans towards the asymptote, but in the middle, does it touch it? We need to check that in number 4. How many times does it touch? So all you need to do is set the equation of the graph x minus 9, x minus 3 into what? What do I set it into? To find crossing points with the horizontal asymptote. We set it into horizontal asymptote equation, which is 1. Alright. Oh, do you remember how I did it earlier? So I just gonna wipe it off and solve it, right? Correct? A ratio set it into number is solved always this way. We wipe off the denominator just like we did here. X minus 9 equals 0. So this is x minus 9 equal 1. We go and do that, right? Right. This is wrong. What I said is correct if the left side, one side is 0. That's correct. This is 1. We need to multiply and literally compute what happens 1 times x minus 3. Look. It's not wiped off. The x minus 3 showed up here. X minus 9 is 1 times x minus 3 is x minus 3 itself though. And I subtract x's and tell me what's going on here. You've proven minus 9 equals minus 3. What does this say? No crossing. Okay? So I will never ever cross this blue line. Wherever my curve is, I will go always above or under of that blue one. Never cross it. That's a fair deal. How about 6? Six is kind of optional. You can still make the perfect picture without it. It's just for assurance. If there is something wrong and you get a function even but it doesn't look like symmetric, then you catch your mistake. This is kind of for insurance. But let's do it anyways. We need to check f of minus x and compare it with f of x. F of minus x needs to be computed in both cases, and we need to compare it to f of x. Are they equal? If you get them equal, then we call it even function. It's even. If the left side is opposite sign of the right side, then we call it odd. If neither happens, we call it, it's neither odd nor even, okay? So let's compute f of minus x. F of x is already known, x minus 9 over x minus 3, right? This is already given to us. What is f of minus x? That means we need to substitute each and every x by minus x. Now what is the relation between left and right side? Are they equal first of all? It doesn't seem so. These two are minus, these are not. I'm wondering, can you cancel these minuses with a matrix? Is there a way to wipe off these minuses? Is there? Look, this has no minus, this has minuses. I think there is a way. Can't we multiply both sides with -1? Remember, you can multiply top and bottom of a fraction with anything you wish. I'm multiplying with -1, and guess what happens? So you thought this is not equal, but I'm proving you that they are equal, because -1 times -x is positive x, and -1 times -x is positive x again. There you go. They are equal. You missed that. Right, Madison? Yeah, I'm trying to trick you, but no. When I multiply with -1, these turn into positive, is still not equal. So there is no metric on earth to make these two equal. They are never gonna be equal. Question is, okay, I got it. They are not equal. However, when I flip the sign of either one, in other words, I'm checking the second one now. Right now, this didn't happen. This didn't happen. I'm checking the other one. If I put a minus to the functions this side, are they equal then? So let's check minus x now. I'm putting minus. This is still a question mark. Oh, when I pass this minus to the top or bottom, you need to pass it to one place. It's minus. You can only put minus either in front, top or bottom, not both top and bottom. I think we have a match now, right? Are they matching if I put this minus here? No. First of all, I didn't put the minus properly. If I multiply minus with x and -9, this becomes plus. The bottom is correct though. Bottom stays the same. So is this a match? These two match, but not -9 and this, sorry. And these are not matching either. So there is no symmetry here. I put minus in front of f and retried, they didn't match. And is there any trick you can do so that they can match? Can you pull this minuses out and make the same? No, even though you pull this minuses out and cancel, this turns into x plus 9, x plus 3. Not gonna happen. So they are never equal. So this case, impossible either. So this function is neither odd nor even. Basically, we are empty-handed. We wasted our time on number, what is this, 6? Okay. All right. Number 7. What does number 7 say? I need the graph here. It says, make a table and get some xy coordinates of points as much as you can. You can do 100 values here if you have time, 100 or 200, 1 million, I don't care. But you need to, for assurance, again, insurance, get at least 1 point between these vertical asymptote, this x-intercept, and between this y-intercept and x-intercept. Get several points around these significant objects. Like I should definitely get some point here, and I need to see where my function going through along in this location. So I'm going to pick something between 3 and 9. Well, give me something between 3 and 9. Like some right between is the best. 6. Let's substitute 6 in g of x, which is, oh, can I substitute? Yeah. What is the equation? It's not, this is in domain, right? Yeah. Okay, we're good. So when I substitute 6 here and there, it's -3/3. That's -1. Am I right? 6 minus 9 is -3. 6 minus 3 is 3. -3/3 is -1. So the first point I got is 6, -1. Where is 6, -1? It's here. So your curve visits this point. Alright, I'm going to pick something between this point and this line now. So give me a value on this range. What is the best value? Right between is 1.5, but I don't like decimals, they are hard to handle. So choose either 1 or 2. Which one? 2. I like 1 better. Why? Why, Maddie? Look, just see the next step, predict the next step. Is it easier to put 2 here and compute, or 1? No, you're right, actually 2 was easier. Yeah, you're smart. Okay, 2 is good. I'm gonna wait. Because if this is 2, that's 2. Minus 7 over minus 1 is also a whole number. I thought it's gonna be a partial number fraction, but you're safe. 2 minus 9 is minus 7. 2 minus 3 is minus 1. So we get 2, 7. Wow, it's a huge value. Please double check my work. 2, 7. I think that's right. You could have gone with 1 as well. If it's 1 minus 8 over minus 2 is 4. 1, 4, 2, 7, both works. So here is 2. 7 will be about twice and a little bit more. There. Okay? Now, and also for assurance, pick, now I have something between these two values. I have something between these two values. For assurances, pick something from the left, far left, and far right. Don't go too far and make 1 million though. A little bit far, like I want to predict where my curve is passing through in this region. Look, do you see the mouse moves? Somewhere here. So I'm gonna go with maybe minus 9 or minus 6. I'm trying to see which makes best. It doesn't matter. Okay, let's choose minus 9. When I substitute minus 9 here is minus 18 over minus 12. That is 3/2, which is 1.5. I was trying to pick a whole number maker, but it didn't happen. That's fine. Minus 9, 1.5 is, it's the right opposite to this here, and 1.5 will be a little higher than this. It's somewhere here. Okay, and I'm going to pick something further than this point. Let's go with 12 or 10. Why don't we go with 10? 10 minus 9 over 10 minus 7 is 1 over 4. That's 0.25. 10.25 is 10, and 0.25 is here. Do you want to go further? Do 12. When I do 12, 3 minus 3 over 9, is that 3 and 9, 1/3, 0.333. 0.333 is a little higher than 0.25. You're here. It's rising. Okay. Anyways, I have plenty data. I have plenty evidence. I can picture this in my mind. Can you picture this in your mind? Can you? If you can, get more and more dots here and there. Alright, here's what I'm guessing. Tell me if I'm right. What is wrong so far? Yeah. Where am I supposed to cross? Horizontal asymptote. Never. We've proven that in step 4, I think. It never crosses. I crossed it. Impossible. Go back and fix it. So if I can't cross and I'm here, what should I do then? How do I go? I need to make some picture on the left, so should I do this then? I'm not crossing now. Are you happy? Are you happy now? No, this is a horizontal asymptote. That means it attracts my curve. My curve should lean towards it, right? And this is getting farther away from it. It's impossible. So you need to start really close to blue line and get further apart and apart. You know, let's do in final graph in this. Go close. We need to meet the red dot though, so don't go too far off. Okay, and then there's a quick change here. I need to go to green dot. And what happens after green dot? Where do I go? Or do I turn back and do this? This is a vertical asymptote. That means my graph will get attracted to it and stay towards it and never cross it. So you need to go to infinity in that direction. Okay, remember you need to keep continuing. You can't have big gaps. You cannot continue here later. You need to pop up right after this electric fence. Where should I pop up? Here? This way? Yeah, this makes sense. Correct? Right? Why not? What's wrong? I disappeared here, so I come back from that side. Makes sense. What is wrong? We crossed the asymptote again. And we crossed x-intercept. We made another x-intercept. There is only one. Impossible. So if I can't go from the top, then which direction should I come from? From the bottom. You need to always come from the infinity. Oh no, I hate this. I lost my pen. Okay, but you got the idea, right? I'm making that picture. Yeah, okay. Just imagine that. Alright? Can you imagine that? Alright, that's our final picture. Question is over. Because if I reopen this, it's gonna be gone. Alright, so why don't we go pick the right choice. But first, let's move everything we found here. There is one vertical asymptote. No, oh, we didn't check the slant asymptote. Is there, maybe you have one. Can you have a slant asymptote here? What's the test? Do we have a slant asymptote or not? Who can say? No. Yeah, there should be a degree difference of 1 between top and bottom, but these degrees match, so I'm sure there is nothing. Vertical asymptote was 3, horizontal one was 1. We found one x-intercept, right? And one y-intercept. X-intercept was, what was it, 9? And voila, we need to pick the right picture. You almost observe here, this and that. Which one is it? It looks like this one, right? Now it's part A. Alright. That's it. We're done. Any questions? Alright, then I'm going to do a general review in the remaining session then. Again, you can try this practice exam as many as you wish. There are how many? 18. I put more, so in the real exam you will probably have less problems. But this is exactly how your exam is gonna look like. There is only one button. You can check your answer right or wrong. If it's wrong, you need to retry. Okay? Again, there is no help options. There is no solve it button. There is no guided solution or a show example button. That's it. Yeah.
You said we're allowed to have a paper with notes on it for the exam. You said it was one side front, right?
Mm-hmm. You got all my email, right? Okay. All right. I'm going to go quickly on these questions, and let me stop me whenever you say, oh, I have no clue how to solve this question, and we start with that. Do you know how to act on this one? These are all from your past homework, so these are nothing. There is nothing new except one question I'm gonna mention. You haven't solved it in homework. I'm gonna definitely solve it today. Slope-intercept form is asked. This is new. I always gave you a new equation formula, and I ask you how to plot this from the main function, but this is opposite. There is a main function given, so why don't we solve this? There is a main function y equals x cubed given. You need to make a new function and find its equation according to these transformations. Alright, this is acting up again today, so I need to restart on this one. This one looks like working now. No. Okay, what do? We start with y equals x cubed, and we transform it according to this recipe, these directions, okay? So first thing we do is, you're gonna shift this graph 5.8 units to the left. And what is the new equation? Every time you make a transformation, the equation will change. And you need to take that y equals x cubed, and it's shift left. What is the left by how much? 3. What is the new equation then? What changes in the formula if you shift the graph 3 left? That's what it's no, it's not 3, I'm sorry. It's 5.8. Yeah, anyone? Do we add, subtract, multiply, divide with 5.8? Come on. How would you do in the exam? That's right, we add to where? Like this? Now this is an up shift. It's going to move all y values 5.8 up. We're not adding to the entire function. We add it to the x, yes. So when I add x, in other words, you remove x first, put it back x plus 5.8, but when you put it back, it was under a cube. So the new 5.8 is also under a cube. Next, step 1 is done. Step 2, reflect across y-axis. So you're going to now reflect this across y-axis. Alright, if you're having a hard time remembering what these things were, keep this table handy. 2.6. What happens when I reflect, or what operation makes a reflection? Does anyone know on top of your head? Reflection along y-axis is done by what operation? Kylie? The entire thing negative? You're right, we are gonna make something negative, but what? You can make the entire function negative, or you can only make wherever x's are negative. They are different. Which one? Ashley says x. What do you say? No. X or y? X or whole thing? Whole thing? Whole thing? Because you want to support your sister. Chris? Okay. X. Alright, let's see what the table says. Where was that entire table? Here we go. If you want to reflect along y-axis, you put the minus into x only. So I'm going to make these x's. I'm going to remove that x and bring it back with a minus. That's it. Okay, next. What is the last step? Shift up 6.2. That's the easiest maybe. How do you shift this thing up 6.2? How? To the end, yes. And this is the new function generated with these transformations. And all you need to do is put it here. Takes a while to type it though, and be patient at this stage. 5.8 added, and then we raised this into power of 3. And always, if you want to move to the ground, use arrow keys. Mouse is tricky. Don't go with the mouse and try to click here. Move with the right arrow key. It's going to be on the ground. Plus 6.2. Okay. Alright, there is another type of this one I think I put next. I want to make a false answer and see if you get another shot. Let's say it's 1 over x. Okay, it looks like same question you can attempt 2 times. After a while it's gonna say stop trying, you're cheating, and it's gonna ask you to solve another question because you're kind of trying to guess the answer. See how many. It looks like a little while. Alright, finally after 4 times, system will cut you off and say you're out of trials, retries, you need to try another one. It tells you the right answer, you need to try another one, okay? So don't try to guess it or you'll lose and brand new question will show up. You have to rework everything, okay? So let's work this one. What is the main function again? 1 over x. What is the first move we do? We stretch vertically. Stretch vertically by how much? 6. Alright, what operation I need to make into 1 over x then? Don't cheat unless necessary. But what is your initial guess? How do you stretch things? Vertically. There is a horizontal stretch, there is a vertical stretch. What's that? Yeah, we need to take 6 outside in front of the whole function and multiply, right? Let's double check. Stretch vertically. Vertical stretch happens if you put that number outside 6 of the whole function. So I'm going to put 6 and multiply with 1 over x. Or can you really multiply this 6 times 1 and make it 6 over x, right? So this is my final product after the first step. I don't want to lose that. Okay. So second step is to reflect it across x-axis. I believe we're gonna put minus somewhere. Where? So in front of the everything or in front of x only? For x-axis, everything. But the good news is you are safe on either choice. You're safe. Even you did the wrong choice and put this minus in front of x only, aren't they equal? Can't you pull this minus in front? So this means either you reflect this function along x or y, you end up with the same object, same picture, so you are safe. But I will still put that minus in front of everything. Reflection along x. Okay? Alright, next we will shift this down 5 and we will be done. So shifting down means was it 5? Yes, just whole number this time. So what do I do? This is your function. How do you shift down? Come on. So multiply? Minus 5. Again, shift down is with a minus that number. Alright, this is the final result. Minus 6 over 5. Okay. Alright, let's continue. Take a look at the other questions. Stop me if you need a review on anything. You're going to determine whether this thing is symmetric with respect to x, y, or origin. You're going to determine the intervals here, where this function is going up, down, or constant. We all done one copy of each question, so I'm going just mentioning each. This is a comprehensive question. A lot of parts, so not every question is worth the same. For example, this one will be a double, triple question worth because it has 8 parts. So I want you to be really careful in changing this into vertex form. Remember, we did that, change this into vertex form. Okay. 2x squared minus 12x plus 17. This needs to be changed into vertex form. To be able to do all these 8 parts, we need to do this vertex form, and you need to do it successfully. If you mess up everything, you'll lose everything. Okay, first step, check the number in front, and if it's not 1, you need to factor it. Is it not 1? No, we factor it. How? Only from the 2 terms, first 2 terms, not the whole thing. 17 is just left. We don't factor it from 17, only the first 2. So it is x squared minus, when I divide 12 by 2, it's 6x. Okay? Next, take more space in that parentheses. I want a little bit first here, because I bet something is gonna come in there. What's gonna come here? You need to artificially add something and subtract that thing off so you can compensate this equation. Add and subtract. What are we adding? You don't remember, do you?
9.
9? Oh, perfect. You guys remember. How did you get that?
You divide by 2 and then square.
Yes, take half and square. Half of -6 is -3, and you square it, it's 9. But I need to compensate for this 9, and I subtract -9, right? So they can cancel off. No. You need to multiply by this and subtract. So it's 18. Good. Good. Alright, next. The reason we did triple trinomial here, 3 terms here, so that we can collapse this, we can pack this into a square. So you really need to guess what number comes here to make it a square. It's not a guess, you actually found it earlier. It's always what? Well, how do you get this question mark? This 3 thing. When you square it becomes this. There's a number here. When you square it, it makes x squared minus 6x plus 9. What is that number? -3. It's this half you found. It's -3. You can find that digit here. 9 is a square of it. It's either positive or negative. It's negative because the middle sign is negative. Okay. What do I do with this thing? I add them up, and it's no longer positive. It's -1. You're done. Vertex form is this. And there was a formula way as well, right? So let's read the vertex. What is the vertex? Oh, it's -3, -1, right? We need to read just these 2 numbers. Agree?
3x1 plus.
Wrong. Yes. It's opposite of this number and this. But there is a formula that tells you the same answer quickly. Do you guys remember that formula? Anyone? If you mess up in part A, you need to use that formula. It's -b over 2a, right? And you use this formula in the function, in this result. What is -b here? 12. 2a is 6. Did you get the same answer? No. No, this is 4. I'm sorry. 2a is 2 times a. 2 times 2 is 4. Did you get the same answer? Yes. This thing is 3. Match. Now how do I get -1? You need to enter this into function. 3 squared times 2 minus 12 times 3 plus 17. I believe you'll get the same answer. Okay? Actually, if you know this, you can get back to this as well. So you can use formula, get the vertex. Once you get the vertex form, you can actually, vertex coordinates, you can get the vertex form by put 2 in front, first coordinate opposite of the first coordinate, and the second coordinate. So you can create a kind of cheating from the formula, but it works, okay? Alright, I'm going to stop for this one here. I think you know the rest of it, right? You can find x-intercept by setting y into 0. You can do y-intercept by setting x into 0. You can sketch, find domain. Do you want me to do any part here? Any part you don't remember? Okay? Alright, this is a zero finding question, finding zeros of this polynomial. There are several ways you can do this question. There is a unique way. One way is, if you believe you can factor it manually with hand, I think it's possible to factor this by hand. It's 4-term factorization grouping method. Factor it. If you don't know how to factor this thing, then what do you do? If you don't know how to factor this to find zeros, what is your alternative? You need to hunt for those fishes, so you need to first create a pool. How do you create a pool of fishes so you can hunt the right ones? What is that procedure called? Yeah, you need to first find rational zeros if there are any. And for this, you need to look at P over Q. P is the nth number and its divisors. So what numbers divide 12? 1, 2, 3, 4, 6, and 12, right? And what are the divisors of the first one? 1, right? Q is the leading number, P is the n number. So the list is 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3. The entire top sequence. So there are 4 candidates that can be 0. How do I test each? I need to test each and catch one fish, and I will use it as a bait. Anyone? How do I test it? Which one is the right zero? These are candidates. Possible rational zeros are there. These are so there are fake ones inside. You need to catch the real ones, correct ones. Come on, what do I do? What test? You do either synthetic division or you just plug this into equation and find one. Okay, I will do 2. I don't know why I skipped 1. I will do 2 because 1 is not working. 1 minus 4 minus 12 is not making 0. Let's try 2 and synthetic division. 1 3 minus 4 minus 12. 1 2 5 10 6. Oh my god, how did I catch the fish in my first shot? I found it, right? It's a 0 because remainder is 0. So I just found that x cubed 3x squared minus 4x minus 12 has 2 as a 0. Am I writing it correct? And 156 the quotient, this second piece, it is x squared plus 5x plus 6. How did I create this? 6 comes first, 5 goes next with an x, and 1 goes last with an x squared. I made a mistake. Where? Right, it's always opposite of this number in the factor. It's -2. And then I just break this manually. You don't need to go fish again. You can just break this by hand. It's x plus 2, x plus 3. I think everyone gets this, right? So what are the zeros? 2, -2, this is -2, and this is -3. -3. There you go. Okay? How else could you solve this? This is the long way. If you're good enough to factor this manually, this was a this can be factored 2 by 2 grouping. Group this and group that and find what's common between them. This is x squared common, right? What is common between -4 and -12? -4. Oh, what a coincidence. These two match. Then factor them again. Oh, this is a square difference. Then what factor it again? Did we get the same answer? Faster? 30 seconds? Yeah, if you know how to factor, of course. If you don't worry. There is a solution for that. You just need to do the long way. Hunt for fishes. Okay? So this question, I think the next one is the same way. You're still hunting, I believe. Yeah. Factor, if possible. Can you factor this? Yeah. Do you see x is common everywhere? And then when I remove x's, and not only x, 5. No, I'm sorry, not 5, 3. 3 is also common everywhere. When I remove 3x here, it's -5x squared plus 24x plus 5. You can factor that again. Easy. Or go hunt for fishes. It's up to you. But this one is just long division. You can do this, right? This is long division. Don't use synthetic here because it's not x and number, it's 2x and a number. There's a way around it, but I don't want you to risk it. Just do long division. Do you know how to do this? You create a polynomial from its zeros by simply multiplying x minus this number, x minus second number, and the leading coefficient. So the answer is 1 times x minus this times x plus 3 root 2. You take always opposite. Okay? You just need to FOIL it. We've done this. Or a possible zero hunt. Right, you're gonna factor 6. We've done this week or last week, I think. And you can go with, okay, can you factor it? It looks like almost this question again, right? This one, so similar, 4 terms. Can you factor this one by hand, like grouping? Look at this. Oops. Can you factor this? I don't think so this time. It looks like 4 term identical questions, but the answer is sneaky. Whoever wrote this question is giving us a false idea. I don't see any. I see something common here. X squared is common, so I remove it, x minus 5. But this one, what is common between these two guys? Nothing. So can I just pull 1 out of them and 5x plus 3? Now can I factor these again? No, they're not common. So this is not factorable by hand. So you need to go fish for this one. You don't have an option. You have to fish. rational zeros. Okay? And synthetic division. Rational zero and synthetic division. That's how you do this one. Alright, we just done this yesterday, I think. When you're on the far left, where does the function go? It's identical, same question, -3. But I want you to see yourself can do this. Can you do all these questions in 90 minutes? Time it less than this, okay? Without any checking out your notes. And find all asymptotes question is here. Does this one have a slant asymptote? Does it have slant asymptote? Yes, it does. So you need to find it by polynomial division, long division, because the power difference is 2 and 1. So it has 1. And I think the last one is a sketching question we just finished this morning. So you know how to do this one too. Okay? So when going back to the first question and everything else, any questions? Alright, just substituting x plus h, it may not be enough for this one. You need to FOIL, multiply out, and combine like terms afterwards, okay? This is a simple slope-intercept form equation. Slope is given, but this is not intercept, this is just a point. How do you find intercept? Do you know that? We need to find slope-intercept form. What's given is a point and slope. Slope-intercept form is y equals mx plus b. So I do perfectly know what m is. I just don't know this guy. How do I solve for b? Any idea? Yeah, just plug in y x this, y that, and get this. You're done. Okay? More questions? Alright, what do you think? I mean, you at this point you should be able to answer this question without pen or paper. Can you do this on manual on top of your head? To check for x-axis symmetry, you need to replace one variable with its negative and see if it goes back to original equation. So what variable do you flip to minus? Y, right? When you flip the minus y with minus y, can you get rid of that extra minus you created? Yes, because absolute value saves our back, right? So we can remove that absolute value. Look, this is what I mean. So you have x minus y minus, let's say 4. So I made this minus y and see if I still have the same equation. Yes, we do, because absolute value and minuses don't get along, they cancel each other. Absolute value removes actually all minuses. So you still have the old one after replacement. This is x symmetric. Okay, how about y symmetry? This time you're replacing x by minus x. But is there any way you can wipe off that extra minus you created? You can wipe it off, but it's costly. You're switching the other side as well. You can take that minus in front of x by multiplying all equation with -1 or minus, and in that case the right side will flip signs and it won't match. So this is not y symmetric, and it's not origin either, because when you flip x and y at the same time, This is staying the same. This is opposite. This is the same. If you flip sides, still not gonna work. Okay? Alright. Final questions. Any questions? Alright, I'll see you on Friday then.